Welcome to our channel. Today, we embark on an exciting journey into the world of programming languages. In this video, we'll explore the definition of programming languages, understand how they work, delve into the process of compilation, and highlight some popular languages that have shaped the tech landscape. So, let's dive in. At its core, a programming language is a set of rules and instructions used to communicate with computers. It enables humans to create programs that computers can understand and execute. Think of it as a bridge between human logic and machine operations. Before we move on, let's briefly explore the classification of programming languages. Languages can be broadly categorized into two main types, high-level and low-level languages. High-level languages are designed to be more human-readable and user-friendly. They are abstracted from the hardware, allowing programmers to focus on the logic rather than machine-specific details. Examples include Python, Java, C++, JavaScript, and C. On the other hand, low-level languages interact more directly with the hardware, offering precise control over system resources. Assembly language is an example of a low-level language. High-level languages require the assistance of a compiler to convert their human-readable code into machine-understandable binary code. During compilation, the source code is converted into machine code, also known as binary code, which is a series of zeros and ones that the computer can directly understand and execute. Compiling code offers performance benefits as the computer can directly interpret the binary code, resulting in faster execution and optimized resource utilization. The compilation process involves several steps: pre-processing, compiling, assembling, and linking. During pre-processing, the compiler handles header files and macros. In the compiling phase, the source code is translated into assembly code. The assembly code is then converted into machine code during the assembling step. Finally, the linker links together multiple object files and libraries to generate the executable binary. The linker's responsibility is to combine the various object files generated by the compiler and resolve external references between them. It creates a single executable file that can be run on the target machine. Once the compilation and linking processes are completed, the resulting executable file is ready to be executed on the target machine, bringing the program to life. Now, let's take a closer look at the compilation process of the C programming language, one of the most influential and widely used languages. The most common C compiler used is the GCC GNU Compiler Collection. When you write a C program, the compilation process involves pre-processing, compiling, assembling, and linking, just like we discussed earlier. In the pre-processing phase, the compiler handles all preprocessor directives, such as including header files, expanding macros, and conditional compilation. During compiling, the source code is translated into assembly code specific to the target machine architecture. The assembly code is then converted into machine code during the assembling step. Finally, the linker combines the object files, including any libraries, to produce the final executable file. Unlike C, Java follows a different compilation process due to its platform-independent nature. The Java compiler, known as JAVAC, translates Java source code into an intermediate form called bytecode, rather than machine code. This bytecode is executed on the Java Virtual Machine, JVM. When you write Java code, JAVAC compiles it into platform-independent bytecode, stored in .class files. This bytecode can run on any device equipped with a compatible JVM. At runtime, the JVM interprets the bytecode and translates it into native machine code specific to the underlying operating system. This enables Java's write once, run anywhere capability. So the JVM's versatility, a Java program can run seamlessly on various devices, from smartphones to servers. Throughout history, various programming languages have been developed, each with its unique syntax and purpose. As technology advanced, so did the languages, catering to different needs and industries. The programming world boasts a plethora of languages, each designed for specific purposes. Here are some of the most popular ones that you should know about. Apart from these, there are many other languages, each with its own strengths and communities driving innovation across the tech landscape. And there you have it, an introduction to programming languages. We've covered the definition, the compilation process, and explored some of the most popular languages shaping our digital world. Remember, learning a programming language is like learning a new language, it opens up a world of opportunities. If you found this video helpful, don't forget to hit that subscribe button and give it a thumbs up. Also, follow us on our social media handles for more tech-related content. Until next time, happy coding.